My name is Kate Anderson, and I'm going to show you how to do the BlackBerry Solar Cell Lab. In order to do the lab, you need a multimeter, a pencil, X-Acto knife, a scupula or a knife, anything to mash, most importantly, BlackBerry. You'll also need a piece of parafilm, as well as 2 small binder clips, and you will have 1 indium tin oxide slide coated with titanium dioxide, as well as a clear indium tin oxide slide. And the final piece is electrolytes. Starting the BlackBerry Solar Cell Lab, the first thing that you do is take your scupula or knife and mash the blackberry. So frozen blackberries work best. You get the most juice that way. All right, excellent. Once you've done that, you then will grab the titanium dioxide coated slide. That is the slide with the white coating on it. The way you remove the slide from the bag is gently, and be sure to hold only by the edges. You don't want your fingertips to have any oils on the slide. So you then identify which side is coated. One side is coated, the other side is not. That can easily be seen by looking at it. This is not the shiny side. You then place it face down into the blackberry juice. You let that sit. Be sure that the entire white coated area is absorbing juice. There's no white spots. You can move it around with your finger to make sure that that's fully absorbed. Stop. While your titanium dioxide slide is drying, you then can remove your transparent slide, which is coated with indium tin oxide, but only on one side. So you'll need to identify which side has the conductive coating. Again, remove the slide using only the edges. To identify which side has the conductive layer, you'll need to turn your multimeter to the ohm setting, which on this multimeter happens to be in the middle. You can hit the select button to get an audible sound for if it is conductive or not. That tells us that this side is your conductive coated slide. So you'll keep that side facing up. And at this point now, you will apply a layer of carbon. And that layer of carbon is applied using the tip of the pencil. So essentially all you need to do is scribble onto your conductive coated slide, paying special attention to these 2 short edges. So you just scribble along the entire slide, holding it in place. It's okay if you don't see a heavy layer of the pencil coating on there. You know that the carbon atoms have been applied. You know that it's on there. Next, you will remove the titanium dioxide dyed slide, your dyed slide. You can use the scupula, you can use your fingers. Either way, you want to flip it so that it's face up and then place it onto the paper towel. You need to now dry the slide, being careful not to rub off the dyed coating, but just gently dabbing using the edge of the paper towel. So as you can see, it soaks up all of that liquid. We want to remove any of the liquid juice from the slide. Easily done by moving it to another part of the paper towel and drying it again. Okay. Excellent. So, see that? For the next step, you will take the parafilm, remove the paper backing. That is not necessary, that's trash. And you'll use the plastic parafilm. This you'll place on top of your purple dyed titanium dioxide slide, and you're actually going to press on directly onto the slide paying special attention to the edge. The purpose of the parafilm is to act as a well. So you'll be applying it to the slide and making a tight seal so that when you put on the electrolyte solution, it will hold the electrolyte solution in place. So once you have the parafilm on relatively tightly, you then will use an X-Acto knife, and the teacher should always do this part. Use the X-Acto knife to cut the area around where you've done the dyeing on the titanium dioxide piece. It's easiest if you hold the edge of the slide and then cut around the rectangle area of the titanium dioxide. Once you remove that, then you are ready to apply the electrolyte solution. At this point, you'll apply the electrolyte solution. We use very, very small amount. In a dropper bottle such as this, you'll only use approximately half a drop. So the idea is to squeeze the smallest amount possible and touch it directly to the slide. At this point, you're now ready to assemble the solar cell. You will pick up the transparent indium tinoxide coated slide with the carbon coating and put it face down onto the titanium dioxide dyed slide. Okay? And at this point, you are now, the easiest way to remove it from the paper towel is to slide your hand under the paper towel and pick it up like that. To hold the solar cell together, you'll put the binder clips on. As you can see, we've left an area of space here and here on the short edges. That's important for the multimeter. It's easiest to put on the binder clips just like this. Put one on the long end and the other on the long end. Your completed solar cell should look like this. Ideally, at this point, you'll be able to bring your students outside and have the students test the solar cells in direct sunlight. So we've come outside, and this first step is to put on the clips to the short ends of the slide of your cell. Once you have the clips in place, not touching the parafilm, you then have your student switch the multimeter volts to the voltage setting. At this point, your student will be able to see the measurement in millivoltage. So for this solar cell, we have a millivolt reading of 390, approximately 390, with a little bit of variation. Congratulations, at this point your students will have successfully made the dye-sensitized solar cell.